I'm Rohan, and this is my Lab 3 black hole presentation. First things first, as opposed to the other labs, there was no real-life video component to this one. It was done entirely on GlowScript. The purpose of this lab was to use our knowledge to determine the mass of a black hole using a star on an elliptical orbit around it. In order to do this, we would have to code using existing formulas to determine parallel and perpendicular forces, and with those we can calculate the mass of the black hole. So this was my program. All right. So these are all of the formulas used. P equals mv, delta v equals v final minus v initial, delta p equals p final minus p initial, delta p hat is equal to p initial over the magnitude of p, f net parallel is equal to p hat times p magnitude of p final minus magnitude of p initial over delta t. F net perpendicular is equal to dp dt minus f net parallel, and gravitational force is equal to gm1m2 over magnitude of r squared. This formula down here is just the gravitational formula rearranged so that it solves for m1 instead of fg. And these are uh, all of the variables here. So this slide here just shows how all of the formulas were converted into code. So as you can see, P is equal to mv, both of these. Delta v is equal to v final minus v initial. Delta p is equal to p final minus p initial. P hat is equal to p initial over magnitude of p initial, and so on. I simplified some of the formulas here so that, as you can see here, this dmag pdt as this entire formula, the magnitude of p final minus magnitude of p initial over delta t, and this is equal to p hat times that, and f net is simply just equal to that. So I just simplified that by replacing these here with this, so that f net is equal to p hat times dmag pdt. And using the values that were given from the code before, I calculated the mass of the black hole. So I used the rearranged version of the gravitation formula to solve for the mass 1 instead of force gravity. And with those masses, I created a blank array to hold all of the individual masses of the black hole at each given point. And then finally, I took the sum of all of the masses and divided it by the length of the list to get the average. Oops. So as far as my results go, the mass of my black hole was 9.97 times 10 to the 33rd, which seems like a fairly reasonable answer. I don't know too much about black holes, so I assume that is a decent mass for a black hole. So what does it mean? The net force and the rate of change of momentum are different. So as you can see here, the net force is the gravitational force exerted by the black hole, so the arrow points towards it, which is the orange here. And the rate of change of momentum perpendicular points to the center of the ellipse. Because the black hole is not in the center and the orbit is not a perfect circle, these two forces will not point in the same direction. However, if the black hole was in the center and this was a circle, they would be the same. So what if the current black hole was replaced with a new one with a different mass, but the ellipse was kept roughly the same? Well, then our situation would be the same as the beginning of this lab, where all of the values are known and except for the mass of the black hole. And we can just use all of the same formulas we used to find the current black hole to find the new one.